Let me start by saying thank you for inviting me to this panel and sharing the perspective of MSD on the footprint of pharmaceutical industry in cancer research and our vision of the future of cancer. Could I have my slides, please?
Slides, please. I'm sorry, there we go.
Okay. So I would like to start with building on something that my colleague Cyril Schiefer mentioned in the beginning, which is to also look at the successes that we have made. And let's be aware that we're really witnessing revolutionary times in the treatment of cancer, with much improved outcomes for patients and declining mortality rates across many cancer types, which is due to improved prevention on the one hand, earlier detection due to screening efforts, but also due to better treatment options. And in fact, we have seen a sharp rise in new drug approvals, a record 30 new substances in 2021 alone, which adds up to 150 new substances in the last decade. So really an immense amount of research and investment in this area of high unmet medical need. And especially with the advent of immunotherapies, we have seen a shift from treating the cancer itself, like we have done with conventional therapies like surgery, radiotherapy, chemotherapy, and also with targeted therapy, to now using or taking advantage of the power of the immune system to recognize and fight the cancer. So this with immunotherapies and in particular with checkpoint inhibitors. So the groundbreaking science by James Allison and Tasuku Honyo, who paved the way for this new class of cancer drugs and to this paradigm shift as to how we treat many cancers today, was awarded with the Nobel Prize in Medicine in 2018, really recognizing the importance of their discoveries. But there have been other advancements. For instance, antibody drug conjugates have shown very promising results in breast cancer, in bladder cancer. And this is chemotherapy specifically targeted to cancer cells via an antibody that recognizes surface structures on these cancer cells. So with this little trick, you can increase the toxicity of the chemo compound, but at the same time avoid off-target effects that will lead to these very well-known side effects of chemotherapy. And then there's gene therapy. Also, gene therapy has shown very promising results. Just think about CAR T cells and their success in the treatment of many hematological malignancies. But I want to come back to how immunotherapy has revolutionized the field. And we've seen broad activity across many cancer types, but I want to reference one very specific example, and that is lung cancer, because it is still the leading cause of cancer death in Europe. Before immunotherapy, a patient with metastatic lung cancer survived less than a year. With immunotherapy, life expectancy has doubled, and in fact, the clinical trials now show that 1 in 5 patients is still alive at 5 years with metastatic lung cancer. So these are really amazing results with great impact for patients. And you can see that these advancements also have impact on how long patients are staying on first-line and second-line therapy. When you look at the slide behind me, comparing data from 2011, 2016, and 2021. So again, really great advancements. So, but what is the strategy for the future? So, encouraged by these great successes in a metastatic setting, these very effective, more modern therapies are now moving to earlier disease stages. And that is very important because we want patients to benefit from these therapies early on in their disease, when the chance for becoming and staying cancer-free is highest. And second, by combining different therapies with complementary modes of action, we're trying to further deepen responses and to extend the window that the cancer is controlled. To this end, we're combining PD-1, PD-L1 inhibitors with conventional therapies on the one side, so with radiotherapy, with chemotherapy. We're also combining them with targeted therapy, but also with more innovative approaches like other checkpoint inhibitors or antibody-drug conjugates, what I mentioned before, or even personalized approaches, such as personalized cancer vaccines, for instance, who will help the body to mount an immune response that is specific to the cancer of that patient. So over 5,500 clinical trials are investigating these combination approaches, and there's more to learn in the future. And with this, I would like to come to my last slide, which is that the future will certainly be to move to a more and more personalized approach. New diagnostic techniques and enabling technologies are being developed. For instance, novel imaging technologies, digital pathology, next-generation sequencing, ctDNA. So all these emerging tools will help us to identify the right treatment for the right patient at the right time. And this is our ultimate goal. Thank you.